Okay, now the final thing that I want to explain on this light bulb example is actually on page 157 in the textbook, and it's exhibit 10.3. Okay, and all I did was took that graph and put it on a single sheet of paper by itself, so it might be a little bit easier to read. But if you'll remember, we looked on page 377 in the book for the critical values for the t-distribution, and we determined that the critical value was 1.833. I'm not going to re-explain how to do that. I'll leave that up to you to either listen to the earlier videos or to look at it in the book. But the point is that the critical value, the critical t-value for this exercise is 1.833. The observed t-value, you will also recall, is 2.957. And our decision rule when using the t-statistic is that as long as the observed t-value, in this instance 2.957, if it's greater than the critical t-value, which in this instance is 1.833, if the observed t is greater than the critical t, you reject the null hypothesis. Conversely, if the observed t was smaller than the critical t, we would fail to reject the null hypothesis. But here, since our observed t-value of 2.957 is greater than our critical value of 1.833, we reject the null hypothesis, which leads us to conclude that the device to extend the life of light bulbs was actually effective. The one final point I want to make here is, as you look at this, you might go, well, that's a normal distribution. Technically, this is a t-distribution. It looks a lot like a normal distribution, but it differs slightly from the normal until you get up to a sample size of about 30. And once you get beyond a sample size of 30, the t-distribution and the z-distribution actually are identical. But here you can see that this t-distribution is set up based on 9 degrees of freedom. So as the degrees of freedom for the t-distribution change, the shape of the t-distribution changes ever so slightly until it gets up to n equals 30, at which point the t-distribution actually looks like the z-distribution.